talked about when you've seen bar graphs is what's called their distribution. So just how on box and whiskers plots, we saw the distribution or the variability along a number line. Now we kind of have that variability or distribution stacked. And we have three types of distributions of bar graphs. So the three are skewed left, symmetric, and skewed right. So the most simple one is symmetric. If something is symmetric, that means it's mirrored on either side. So the middle graph here is symmetric. We drew like a line, like your axis of symmetry down the middle. It would be mirrored on both sides. When we say a graph is symmetric, it doesn't have to be exactly symmetric, but if you can kind of draw this mountain shape over it, where there are mountains in the middle, it's symmetric. Our two other ones are skewed left and skewed right. And these are confusing because it's where the graph is, it's actually the opposite. So even though most of our data is to the right on here, right of our graph, it's skewed left. The easy way to think of it, we call this the lowest point, or kind of our slope down, we call our tail. Wherever our tail is, what side is on, that's which direction we call it skewed. So since here, our tail is to the left, we call it skewed left. And here, since our tail is to the right, we call it skewed right. Besides doing that, just knowing our distribution, we're going to make these bar graphs, and I kind of set up as easily as possible, I think. So instructions are to draw a histogram to show the number of raffle tickets sold, and then we just want to describe the shape of the distribution. So a good graph here will have a few things. First, it'll have labels on our axes. So in our box, we have frequency. So frequency means like number of times it happens. And these are our number of tickets sold. So between like 1 and 8 tickets sold, that happened 5 times. Between 9 and 16 tickets sold, that happened 9 times. 17 and 24 tickets sold, that happened 16 times, and so on. So you're always going to label your frequency as your x-axis or your horizontal axis. So we'll put there, we'll say frequency down the bottom. And then our whatever other unit we're talking about, that'll go along our y-axis or go vertically. So that'll be tickets sold. So kind of each section is going to be kind of a part of our graph. So instead of a graph, like normally go like 1, 2, 3, 4, 5, 6, a whole space that we're going to have is going to be like 1 through 8. So since we have, it's about, I think it's 20 across, and we have 1, 2, 3, 4, 5, 6, 7 bins, we can call them. If we make each bin have like a width of 3, we'll have enough space. So what I mean by that is, so like our first 3 boxes, we're going to put the frequency of if you sold 1 ticket or 8 tickets. So 1 through 8. If you don't like writing like up and down like that, you can kind of do it diagonally. It's a little easier to read. So it's like 1 through 8. And then we're going to split up into another, moving over 3 boxes, and that'll be kind of our next bin. Our next bin was, zoom out, 9 through 16. So that's what we're going to label our down here. So 9 through 16 tickets. And then we keep just splitting up by 3 boxes each time and keep labeling. So it goes 9 to 16, 17 to 24. Move another 3 over. We get it to, sorry, I keep zooming in and out. You have it on your paper. 25 to 32. Right. Then move over another 3. So that next 3 will then be, just gonna get out a note so I can look. We're going 33 to 40. And then another 3, 41 to 48. And then 49 through 49 through 56 is our last bin. So you have to label that axis every time. And then we also need a label for our number of tickets sold. So before you just assume you want to go by 1, we have to get up to 25. And there's about, if we go up 1 extra, there's 25 boxes in total. So it makes the most sense to just go up by 1 each time. That's not always going to be the case. Sometimes it would make more sense to go up by 2s if you need to reach a higher number. So again, your scales can always change on this side, but your bins are kind of already set for you that you have to use down here. So what I like to do instead of labeling like just each one, like 1, 2, 3, 4, I like to go by 5s. So I just say, okay, well, I know this is 1, 2, 3, 4, 5. I know this is 5 right here. Then I go up another 5 and I mark 10. Then it's just a little less messy. 5, oh, where'd it go? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then 25 is at like the top of the arrow if you were to add an extra line in. So zoomed out, this is what, that's the most like tedious part because there's just a lot of labels. You got to make sure you're labeling everything. And now we use our frequency values to actually make the height of our bars. So in 1 through 8, so the number of tickets sold, that happened 5 times. So we draw a bar in this 1 through 8 box up to 5. And then if you want to do like a little light shading, especially if you're writing in black, that sometimes helps a little bit. And then 9 through 16, that happens, the frequency of selling 9 through 16 tickets happens 9 times. So then we draw our bar up to 9, which is right below 10. Then we can do our next one. 17 through 24 happens, the frequency is 16. So we have to go just 1 above 15. Again, do some, yeah. Do some little shading just so it kind of pops out on the page. Then we just keep doing the rest. 25 through 32, that one goes all the way up to 25. So that's going to be our highest one. I know it's difficult. Try to follow your lines, make them as straight as possible so you have nice straight towers. $33 to $40 happens 20 times, and now our labels are really helping us. Go all the way up to 20. 41 to 48, the frequency is 8. And then 49 through 56, that is 7. So you have a graph now. Now a bar graph, or again, it can be called a histogram. Sometimes you'll see people also, they'll label kind of above. Like this is 5, 9, 16, 25, 20, 8, and 7. That's not a required thing to do. Sometimes that kind of just helps you at whoever would be reading your graph can read a lot quicker then, especially if your numbers are small. So naming the type of distribution this is, we can kind of, this makes, it's not perfect, but it does make kind of that mountain shape in the middle. And through our middle here, it's somewhat symmetric as going down on both sides. That's one key to know it's a symmetric distribution. If you have like kind of a peak and each side is going down, it doesn't get higher or lower, it just keeps going down. So we would say the distribution is symmetric. All right. I gave one other example on the back that we'll do together. Before I move on, does anybody have any questions about how you make this? I'm sure you've done this in science at least once, and probably in math. In middle school, you definitely made a bar graph. I can say for sure. All right, let's go to the back. So this is the amount of garbage collected in pounds. So again, if we were to label this, our x-axis is our frequency. Our y-axis would be our garbage. And since we have 7 bins again, it works if we just split it up into 3 boxes for each bin. So we can make sure that we're using our whole graph. It's not too narrow, easy to read. So I'll label the first 3. This will be like your 1 through 10. Just using your amount of garbage values that you were given. Our next one would then be 11 through 20, so it's just going up by 10s. So this one would be 21 through 30. Then we would have 31 through 40. And then you maybe have the pattern now, 41 through 50. 51 through 60. And then 61 through 70. Yeah.
What if you're starting at the room to let out how do you do this?
Like if this were both, like if this was 30 and 30.
Like if 1 through 10 was 5 and 6.
Oh, then they're just going to be at the same height when you make your bar graph. No, that doesn't matter. They don't always have to be. That maybe will change what the distribution looks like, but they can be the same height.
What if there's any difference in that?
That's still fine. So if you look at the frequency that's happening in our table, we have 7, 8, 10, 16. We go all the way up to 34, and then 15 and 0. So if we go by ones, we're not going to have enough space. But if we go by twos, we'll be able to fit everything in. So I'm going to scale my garbage access by twos. So I'll say, and again, I'm going to count by twos. 2, 4, 6, 8, 10. Again, just to make it easy, don't label every single one. 12, 14, 16, 18, 20. 22, 24, 26, 28, 30 up here. 32, 34, and that's as high as we're going to go, so that's as high as I'll label, just to 34. And then we can go in and again make our table. So, yeah. If I make each box is 2. So 2, 4, 6, 8, 10. Instead of 1, I'm going up by 2s. So we have to go to 7. That's halfway between 8 and 9. So 2, 4, 6, 8. Oh, sorry, halfway between 6 and 8. So we go right here. 2, 4, 6. 7 is halfway. Our next box, we're at an even 8. So it's just slightly above. Again, this is kind of where your straight lines matter. 21 through 30, we get up to 10 pounds of garbage. Sorry. And then 31 through 40, we get to 16. So that's 2, 12, 14, 16. Now we're all the way up to 34, so we marked it so we can just go straight up. Uh, 51 through 60 is 15. So we gotta go right below where our 16 mark was. And then our last one is 0. So this distribution now is all of the data is kind of centered over here. That's where most of our data is. That means our tail is over here. And remember, whichever side of your graph your tail is on, that's the way it's skewed. So this would be skewed to the left. So for distribution, you'd write skewed left, and we also know it's skew left because it kind of follows this, where we have a bunch of low values here and we have a higher value farther to the left, to the right. And you go opposite. All right. So everybody turn to your yellow sheet. I made a copy and paste error, of course. It wouldn't be a worksheet that I made without you having to change something. So you only have, 9 days left of having to change things. Change my mistakes. So let's see where I put it. Just on the second table, you got to change the numbers because they're the same as the first problem.